Ashley and Westbrook. Want to put this one on the board for us? Thank you. Want me to do it then? We can orient that at a different time? Okay. All right, what will be the sign to the right of negative 40? And then, of course, negative for the left. Okay. So, if it's negative, what's my absolute value going to be in this region here? X plus 40. Okay, and what about in this region here? Okay, so I'm going to write the absolute value of x plus 40 is equal to, we do the positive one first, gives x plus 40. Okay, notice that the positive is there, we can put if. What would I write? Put x greater than or equal to negative 40. And it's equal to what will be the bottom one here then. You want to go, we can use the brackets more. Yep. So we'll do that. Negative 40? Yeah. Notice it's not equal to. Any questions with that particular one there? I guess I should probably fill in my other bracket there. Was you getting much of a delay right now? Okay, good. I'm just curious because I'm recording this. I want to know if it was going to go a little slower. Any questions with you, Westbrook, though? Okay, Tony, I'm assuming you guys are good. I'm confident with you guys today. If you have a problem, make sure you just interrupt me, please. Try this one. Done the same way. The last one. Except you went the factor to get your bracket. So you're going to have two brackets of your one alone this time. Still do the test. Make sign analysis. No different than if I were to just ask you to find words greater than 0 or less than 0. Just give you a heads up. Two intervals that accomplish property. We can use union to help us convey that in our answer. We're going to get going on this one. what I did when I factored this. I got 4 plus x and 4 minus x. Okay, so I had 2 zeros, negative 4, and positive 4. I hope that's okay. And here's my sign analysis. I'm going to get a negative value in this section. I'm going to get a positive value in that section, region. And of course, a negative value in that value in that. Okay, good? Okay. The one thing I want to make sure everyone's okay with, this is a difference of squares, people, but this is not equal to this. You can't just say, I move x to the front. X is a negative, it's going to be that factor. So don't get caught in that half. This is equal to 4 minus x, 4 plus. It's wrong. And be careful how it's written. So, moving down here, whenever I see a negative region, I see a negative round bracket. Whenever I see the positive region, I can just grab the brackets all together. And once again, I got 2 negative regions. So here's going to be my final answer. It's going to equal to 16 minus x squared if x is an element of negative 4 and positive 4. And we include the closed brackets.
So we always have closed brackets
When it's positive, yeah. So 0 is a non-negative number. Okay. Did you guys hear that question, guys? Someone asked me if we always use closed brackets when it's a positive question. And my answer was yes, because when it's equal to negative 4, you can see that that value is 0. And we should know by now that 0 is a non-negative number. So it is okay in terms of our absolute value. And then the bottom half of our answer is negative fraction, 16 minus x squared, and that's when x is an element of negative infinity. All this region is highlighted in yellow, all the way up to negative 4, not including it. Union 4 to positive infinity. So that's the more target those types of questions to get. So if you were good with that, then I'm happy. Any questions? Tony, I think we're good. Or do you guys have a question? All right, balance is golden. All right. Showing here are some just operation properties regarding absolute value brackets. The first one is our product property. So I've got the absolute value property or product of B and C inside my brackets. What I can do is I can rewrite those as the product of each, both with absolute value brackets. Same goes with division, provided that your denominator is not equal to 0. If I've got an exponent inside my absolute value bracket, I'm allowed to move that outside. And the last one, the square root of b squared is equal to the absolute value of b. Now, show that the absolute value bracket, that particular expression is equal to the positive of x plus 3. And here's what we do. Also provided that x does not equal 3, because if it were, you can see we would get 0 in the denominator, so that's not allowed. So what I do is I first, I'm not sure why I wrote that down twice, but whatever. My absolute value bracket, and what I did was I'm going to factor my numerator. Okay. When I take out a negative 1, Why am I taking out a negative 1? So I can switch the sign. Good, and I cancel one with my numerator. So this negative 1, he should have had it basically like this. So it's going to change it to the 3 minus x, and he still has the x plus 3 all over. Now he was able to cancel this bracket with that, and then he's left himself with inside the absolute value bracket negative 1 times x plus 3. And then use the product property. Speaking up here for a second, he's got negative 1 times x plus 3 absolute value bracket. So what he did was he separated those two into absolute value bracket of negative 1 times the absolute value bracket of x plus 3. If you look at this first term, the absolute value of negative 1 is positive 1, so I got positive 1 times the absolute value bracket of x plus 3. Positive 1 times that is simply equal to x plus 3, which QED does to our right-hand side. Okay, so this is a question where you're manipulating your products, the properties, a little bit of the quotient properties, and coming up with a proof that that's equal to the absolute value bracket of x plus 3. Everyone okay? All right. Kind of apologize for the quality of this next little bit. Everybody try to make it large enough for us to keep it kind of loose with this quality. This is in your textbook as well. It'll print out fine, I think, when you do it. It'll just give it smaller. I want to focus on this equality property first. The absolute value bracket of anything is equal to b only if and only if star is equal to b or star is equal to negative b. So, for example, negative 5 is equal to 5 because b was equal to negative 5. And this is something we've already talked about. Okay? This is from another line. Inequality property, though, is something going to be new. Now, if the absolute value bracket of star is less than or equal to b, then negative b is less than star or x, which is less than or equal to positive b. Okay. Let's look at do I have that one? Right here. So we got absolute value 2x plus 3 is less than 11. So this is very similar to the first equality property we did. So that means that negative b is less than equal to a. With you can drop your absolute value bracket, which is less than or equal to b. So I simply rewrite this as negative 11. What's in the absolute value bracket? Less than 11. Now we're just solving this inequality yesterday. Move the 3 over to both sides, subtracting it, dividing by 2. I'm saying x is greater than x to 7, but less than 4. So you can write it in your set notation. And there's my answer to the question. If I go back to that again, that's only when it's less than or equal to b. If it's greater than or equal to b, we've got a different situation than that. If that's the case, we've got star is greater than or equal to b, you set up two equations, so I'm using kind of the middle inequality. You say star is greater than or equal to b, and star is less than or equal to the negative, whatever the other side is. Okay, so you've got two equations. As you can see here, we got one that's greater than a number. So what I'm going to do is I set up two equations. I drop the absolute value bracket. So greater than the positive, less than the negative. And way to remember that kind of is you switch, when you divide it by a negative number, you switch the inequality sign, correct? So this 28, when I make it negative, I kind of switch the sign. When I do switch the sign. And that's the way I personally remember when I do these types. And then you just simply solve for both. So I get the following. X is greater than 12, or x is less than negative 1 over 3. So how would I write that? And I want you guys to, if you have the notes printed off, don't cheat. But how would I write that in this type of notation? Do not be distracted. Or it's on the back of the page. I'll give you a hint about trying to not make you feel like you made a mistake. Your answer will contain a union. If you don't have a union, you've done it wrong. Now, if you're one of those people that didn't have a union, I want you to think about what is being said here. I'm saying x is greater than or equal to 12. Or x is less than or equal to negative 1 over 3. Think about that. X has to be greater than 12, greater than or equal to. Or it can be less than or equal to negative 1 over 3. I'm hoping infinity is popping into your brain at this moment. Save a little time. Here's what I got from mine.
Does it matter if you have like the...
Yes, it matters. You've got to go left to right. You can't have this right. So this one here represents the negative infinity all the way up to negative 1 over 3. That's good. It's got to be less than negative 1 over 3. In this bracket, all numbers greater than or equal to 12. It's all the way up to infinity. Of course, you close the bracket. Hey, Tony, can you guys turn your microphone a bit? How's everything going today so far? No problems at all? Excellent. All right. That's good. The equality property, we didn't do any questions with this yet, but it's a lot easier. So I wanted to go through this a little quicker. I want to do these ones first because they involve a little bit more thought. Equality property, basically set up two equations. Drop the absolute value bracket equal to the positive, and drop it equal to the negative. So I got this one here. Okay, and notice that this is only for when it's equal to something, hence the equality property. When you deal with the inequality, you have to remember to do inequality property. But here I got it equal to, so it's very straightforward. I drop the inequality, I drop the absolute value brackets, and I make two equations. The one in left in green, where it's equal to positive 86, and the one where it's equal to negative 86. Okay? Now they're dealing with equals. You just solve it like you did back in grade 9. And when you solve for something when it's equals, you have a solution set. Right? You're solving for x. So I get two values, negative 15 and 97 over 5. In fact, we did do this. Here's another one. 5x minus 3 is equal to 7. I drop the brackets. 1 equal to the plus, 1 equal to the minus. Solve for each. Typically, you'll want to write your smallest number first in brackets. So I write negative 4/5 and positive 2. Assuming we're probably all good on that. That one. All right, I'm going to leave this challenge question if you want to do this on your own time. Okay, the notes are there for you. It's got some fun parts to it that you have to think a little bit through. And I want to jump to graphing. Okay, I want to finish it today. So, if you were to graph y equals the absolute value bracket of star, all we simply need to do is sketch the graph y equals to star. Just graph the regular function if there were no brackets there at all. So if I've got this function, you can see what I do graph it, sorry that I went right through it, is 1/2 x cubed minus 2x. And I get this shape here. Now, if I were to graph the absolute, I'd simply take the parts that are below the x-axis, which are going to be in green here, and I reflect them. We all know what reflection is, along the x-axis. So at this point with -2 and -1, it will become -2 and +1. So it's going to be up here. See this portion here is this part going up. Okay, it's a mirror reflection. This portion in green here will become this portion in blue, leaving us with only graphs that is above the x-axis. If you think of it when a function is negative, it's below the x-axis, here, and in this region here. We can't have that for absolute value graphs of functions. So we just take the portions that are below, reflect them on the x-axis, and then continue with the regions that were already above the x-axis. Yeah, that's good. David?
Can you remember how to draw the graph to begin with?
Yes. It was ours. So we asked if we knew how to draw the graphs, we would just keep it with ours. Okay? All right, on page 46, I've got some questions I want to do. I want number 1, 2, 5, 6, 9, 10, 17, 21, 22, 26, and 49. 49 to we got a few minutes to work on that. If there's any questions, yeah. But if not, we can start up on the assignment. I'm assuming that we can probably get this done for tomorrow. All right, no questions, good enough. All right, well, I'll leave the mic open. If you want to yell at me for questions, please do so. Other than that, we'll talk to you guys tomorrow.